Hello everyone, it's Mr. Wolf here, and in this video I'm going to be going over number 2 for proportional reasoning. Miss Dean is driving her car down a road in the woods. Right? By the way, if this is proportional reasoning, first thing I want to do is make this chart where I am differentiating between my actual numbers and my factors. Okay. So she's driving down a road in the woods. All of a sudden, a deer jumps out in front of her car. She slams on her brakes and skids for a distance of 12 meters. All right, so my distance is 12 meters. Do I put it in this column or this column? Well, it's got some units, so this looks like it's an actual distance in this case. All right, so I'm going to put under the actual numbers column, distance is equal to 12 meters as she comes to a stop. All right. So by the way, that would mean our final velocity would be 0 meters per second. That's an actual number 2. Right. Let's see, by what factor would the stopping distance change if she was driving 1/4 the original velocity? So I think this is one of those important problems that just kind of shows how fast you are going could really amplify how long it takes you to react and stop, or at least stop once you do react. So let's see, by what factor is the stopping distance change? So again, I'm looking for a factor here, so I'm going to put distance equals question mark. I am not going to put distance equals question mark for this column. If she was driving 1/4 the original velocity. All right. So 1/4 I'm going to put in for my factor for velocity because there's no units here. This is a factor, not an actual number. All right. Well, she's driving. It looks like we're going to assume that she's driving like the same car and everything. The only thing that's different is that she's not going as fast. So it's going to be the same mass of the car. All right. We're comparing the same car, which means the car doesn't change. So my mass is going to be 1 in this case. All right. And then we are also going to, I need to specify this when I rewrite or make some revisions to the worksheet, but I will make sure to say that, just be explicit, that it is the same force that she is applying with the brakes. So the same force. All right. So I'm going to say if that's the case, my force is going to be the same, so my force is going to be 1 in this case too. And this is an accidental scribble. All right. Now I'm going to make my LOL so I could build my equation so I could actually solve for this factor. So driving before braking. I'm going to ask my question, is there height? Nope, no height, so no UG. Is there velocity? Yes, she's driving, so I'm going to have some kinetic energy. I could draw 1 block, 2 block, 3 blocks. I'm going to draw 4. And then afterwards, she's stopped. So again, is there height? No, she's on the ground. Is there velocity? No, she is stopped. So there's no kinetic energy, which means my energy must have left my system. Do I have a cause for that? Let's see. Well, yeah, she slammed on her brakes. There's definitely an outside force there, right? So I have work energy leaving my system, and it's caused by, you could say force push, like the force of the brakes, or you could say force of friction. All right, I would take either of those. Force push, depends on how you think about it. I would take either of those. All right, so in terms of my energy types here, all my energy is in kinetic energy at the beginning, and then it looks like we are going to subtract work. I'm doing this below just because I ran out of room here, and that's going to be equal to 0 at the end. Now, like I said, I just don't like having my equations be equal to 0. I like getting kind of 2 things on the same side. So what I'm going to do is I'm going to add work over to the other side. So instead of being k minus w equals 0, it's just going to be k is equal to work, which makes sense. Here's my kinetic energy. All that energy leaves as work. They're the same. 4, 4. Cool. All right, so now let's expand out this problem. K, my equation is 1/2 mv squared. For work, it's force times distance. I am looking, again, for the factor that the stopping distance changes. So that's what I'm looking for. So I'm going to write down D here. And then I'm going to see, all right, how do my other variables change? My force, again, is going to be the same. So 1. My velocity is, she's driving 1/4 the original velocity. And that's going to be squared. My mass, it's the same car, so that's 1. And this is proportional reasoning, so we do not care about this 1/2 at all. It's a constant. All right. So now I just need to do the math, right? 1/4 squared. All right. Well, how we do this is you square the 1, you square the numerator, then you square the denominator. So 1 squared is 1. 4 squared is 16. So it ends up being 1 times 1/16. So on my left side, I'm going to have 1/16. Is equal to, well, 1 times d is just distance. So boom, I've actually already solved this. My distance is 1/16 times as much. So just by going 1/4 the distance, we really decrease that stopping distance. All right. So what's the new distance? Well, if it originally took her 12 meters to stop, I'm going to multiply that by my factor, which is 1/16. Right. And then what we end up getting is 12 times 1/16. You do this in your calculator. You're going to get the new value to be 0.75 meters. All right. Thanks for watching.